Yeah! You want to do your homework, huh? Well, let me help you out with that. W1.2, Scientific and Standard Notation. So this is not a particularly complicated homework. However, you may find a little bit of assistance from Mr. B to be of nice help. Let's go here. 7.90. We're going to turn this first part into scientific notation. You're in standard format. You may say, what am I doing? But listen, just put it in scientific. So we want standard, which means a single non-zero and then the decimal. So we're already in that. 7.90 times 10 to the, well, we didn't have to move the decimal at all. So this is times 10 to the 0. Cool. You'll do the same thing down here and you get to number 2. Here you notice you are not in standard. Your decimal is not immediately to the right of the first non-zero, so you're going to have to move this decimal over, and then you'll put your number over here on line 2. And keep in mind this was a small number, so that tells you what kind of power it should have. All right, once that's set, I also want you to come up with the order of magnitude. So the order of magnitude, remember, is just slang for the power. Well, the power here is 0 on the very first one. So you would come down and write 0. Okay. However, remember we had to round. Rounding was based on the coefficient. It's also written right up here. The coefficient rounding point is root 10, which is 3.16, basically near pi. If your number here, the coefficient, is greater than 3.16 or equal, you will round this order of magnitude up. In this case, we have 7.90, so 0 rounds up to 1. There's your answer. 7.90 times 10 to the 0 is standard scientific, order of magnitude 1. You can do that with the others. Get down to questions 5 through 8. Convert into standard notation. All right? So standard notation, of course, you want to get rid of the power. In fact, this 10 to the minus 2 is just an instruction for the decimal. Well, you see the minus 2. That, of course, means a small number, so make this smaller. How many times smaller? 1, 2 slots. You'll fill a 0 in one of them. Your answer will be 0.071. And the way I group things by 3 is I'd leave a little gap, put a 2. You don't have to leave a gap. So there is my standard notation. Now, the order of magnitude, remember, was slang for the power. So when you're doing order of magnitude, you do not want to look at the standard notation. You want to look at the standard scientific notation. And so in this case, your answer would just be slang for the power minus 2. And then you have to decide, does this 7.12 round us up? Answer, yes, it's greater than or equal to 3.16. So this becomes negative 3. There it is. So your answer to 5, 0.0712. And the order of magnitude is negative 3. Good. Just beware, as a warning, we'll go back to question 2 up here. When you decide order of magnitude, you must be looking at your number in standard scientific notation. So if you came over here and put like a 0.115 times 10 to the 0, well, that's not what we're looking for. You need to move the decimal, make it standard scientific, and then from that you can determine your order of magnitude. All right, come down to questions 9 through 18. You're going to calculate using the EE button plus your brain. Yes, you have a brain. The brain is for this part. It's called ITR. Is this reasonable? Answer, depends. Well, let's see. Is this reasonable is essentially a way to estimate the answer, to get the magnitude approximately of the answer, or even the order of magnitude. So here we have two numbers are multiplying. 2 times 10 to the third, 4.2 times 10 to the fifth. Multiply it all together, what do you get? Now, this is very easy to put in your calculator and get an answer. In fact, when you do it, you will get, I'm not going to tell you yet, but you'll get an answer. How do you know if your answer is correct? How do you know that you didn't hit a button in the calculator? In fact, how do you know when you get to a question like 16, which has extreme powers compared to what you're accustomed to? How do you know that you didn't somehow make a mistake? Method? It's called, is this reasonable? It's basically a way to make sure you didn't mess up. Just look at the powers. 10 to the third, 10 to the fifth. You're multiplying them. In case you forgot what to do, this, by the way, you should know. Over here, when you multiply 10 to the third times 10 to the fifth, the shortcut is to add the exponents. So what's 3 plus 5? 8. You should approximately get 10 to the eighth. Or you could even just write 8 for an order of magnitude. Now when you punch it in your calculator, which I want you to do, you will end up getting 8.4 times 10 to the eighth. And the question becomes now, is this 10 to the eighth, order of magnitude 8, is that reasonably close to what you got on your calculator, 8.4 times 10 to the eighth? It is. If it's reasonably close, within about a power or so, then you know you did the right math. Keep it moving. If you estimated 10 to the fifth, is this reasonable? You got 10 to the fifth and you get 10 to the ninth on your calculator. It's time to get a little nervous. You better go double check what you did. So you're going to do that for all of these. In fact, the part where you have to use your brain is this reasonables? So is this reasonable? Is this reasonable? You look at the powers, follow the process. When it comes to addition and subtraction, that's actually a little more difficult. Multiplying, dividing, even raising to an exponent over here, those are pretty easy. Addition and subtraction, yes, you're supposed to make the powers the same, but usually the big power wins. So you take an example up here, like number 10, you get 10 to the 6th plus 10 to the 6th. Well, it's usually going to end up then 10 to the 6th. If the powers are the same, it usually stays the same. If you add instead 10 to the 6th plus 10 to the 2nd, big power usually wins there. You'll probably end up with an is this reasonable of about 10 to the 6th, which we sometimes can just write this as 6. All right, so go through these. And you can see over here you get to 16, a little more complicated. You got to do a power, you have to do a multiply, then you have to do a divide. But the truth is, you can get a pretty good idea of whether your answer from the calculator is good to go. Oh, what is this? Yes, look down here at the bottom. Ooh, what's that? That's an answer key. Why? Because I'm not that interested in the answers. You see, the next time you do one of these questions, it's going to be a new question with a new answer. So the answer is not really the focus. The answer just lets you know if you followed the right process. The process is the focus. So if you notice down here, go through questions 1 through 4, then come check 1, 2, 3, 4. Does your answer match the key? If it does, you can feel confident that your process is good to go. I did not put in the order of magnitudes in the key because I want you to actually think about those on your own before we talk about them. So same thing for the rest of these. Check your answers. The is this reasonables are not down here, but you should take your time to try to get those. This is what turns a 98 or a 99 into a 100. And does that matter? Of course it does. It also could turn a 76, 77 into an 81 or an 82. These little things here get you over the hump, so to speak. Now the other part of your homework is W18. You know what? We'll make that a separate file. Nice talking to you.